Volcanoes in space. All right, so the reason that I chose this particular topic was because as a small child, I saw this movie, Volcano, with Tommy Lee Jones in it. Very good movie. But 5-year-old me was terrified that at any moment, one day, right, I would wake up and there would be a gigantic volcano right here in Queens, New York. Um, as a 5-year-old, I was very convinced of that. Now, as an adult, I know that that's not going to happen. But I also now know that there are volcanoes other places aside from Earth. So, what is a volcano anyway? And no, I don't mean that kind of volcano. As a chemistry teacher, I see a lot of those. I'm talking about volcanoes that come out of the Earth. So the solid core is rotating and moving around inside that liquid core. As you move further and further away from the inside of the center of the Earth, the rock, right, the liquid rock cools and it gets more solid. So up at the top, we have the crust, the part that we're familiar with, right, the dirt and rocks and everything. And right underneath, well, not right underneath it, it's a little bit deeper than, we're able to dig, but there is liquid hot magma, right? That magma is in the upper mantle, and because the Earth, right, the core inside is spinning and moving around, it heats it up, and the magma sometimes needs to relieve itself, right? It needs to release some of that pressure from the heat building up. So builds up, and then at some point, it breaks through the crust of the Earth, and we have a volcano. So you might be wondering, magma, is that the same thing as lava? No, it is not. The magma is when it's underneath. Lava is when it comes out. So when the lava comes out, it goes on top, cools, and forms a layer of rock. And it keeps repeating this and repeating this and repeating this until we have a nice big volcano. So we're going to take a look into our solar system. I'm going to move over here. I'm cropping Pluto out of the family picture. Sorry, Pluto. So we're going to start at Mercury and work our way away from the sun. Okay, so Mercury used to have a lot of volcanoes, but it doesn't anymore. It hasn't for about 3 billion years, I would say. So the way that we know that there was volcanoes on Mercury is similar to how we know that there were volcanoes on our own moon, which we will get to later. You can see here in this picture that there are these circles. Those are impact craters from space stuff smashing into Mercury. Mercury doesn't have much of an atmosphere to protect it from all those asteroids, so makes a crater, right? And back in the day, 3 billion years ago, when it hit, it would stir up a volcano. The volcano's lava would come out and kind of smooth things over. So why was it 3 billion years ago? Well, Mercury dried up, basically. So if you picture like an orange, let's say, that loses its moisture, right? It kind of shrivels up. That's basically what happened to Mercury because it's so close to the sun. And right, once it shriveled up, that kind of just killed out the volcanoes. No more volcanoes on Mercury. But we can see from these nice pictures that there were at some point. These are really good pictures, right? So on the bottom right here, we can see the lava flow. That definitely looks like lava, right? Next up, we have Venus. So I was saying that Mercury has no atmosphere. Venus has quite the atmosphere. Very dense, very thick, heavy atmosphere. Also, the volcanoes on Venus are different because the lava is very viscous. So viscous means how liquidy something is, basically. So if you have water and you have maple syrup is much more viscous, right? It's thicker than water. So the combination of having that really heavy atmosphere and the really viscous, sticky, right, doesn't flow, that kind of lava, that gives us what are called pancake domes. So if we take a look here, right, the circles that we see, they kind of look like pancakes. And on Earth, right, when we have a volcano, it goes up and then it, does its thing. On Venus, it kind of just oozes out and flattens, right? Atmosphere is pushing on it. There's also these things called arachnoids. They suspect that it might have something to do with volcanoes, but they don't actually know. I just thought it was interesting that they were called arachnoids. Earth. I'm gonna kind of skip over Earth because we're here and I don't know, it's not as interesting as space. But this video, you should, it's over there. This video, you should definitely watch it if you have 5 minutes and maybe you want to cry. It has nothing to do with how volcanoes actually work, but it's super cute. It's a short Pixar film about volcanoes falling in love. That's all I'm gonna say. It's adorable. You should watch it. I'll put the link in the post. Also, volcanoes are how we got Hawaii. So thanks, volcanoes. All right, Mars. All right, let's take a look at Mars. So Google has this really cool thing called the Mars map. So it's like Google Earth, but Google Mars. Isn't that fun? So you can actually look around and explore Mars. And if we take a look here, right, white corresponds to 21 kilometers. Right here, we have a very tall one, right? So this is called Olympus Mons, the biggest volcano in the entire solar system. Winner. That's it compared to the size of Arizona. It's pretty big. Makes Mount Everest look like an anthill, pretty much. So terrestrial, meaning that they're made of rock. Jovian, meaning that they're made of gas, right? So if there's balls of gas, that means there's no solid ground, no volcanoes. But wait, there's moons. See what I did there? All right, so I'm going to start with our moon since, sorry, moon, it's probably the least exciting of all the moons that I included. As I said before, the moon has, or had volcanoes as well. And the reason that we know that is from the Maria. So Maria, it's spelled like Maria. The singular tense is mare meaning sea, right? So back in the day before we got to the moon or got a really good look at it, they were looking at the moon and they thought that there were oceans on the moon. These Maria have, they're nice and smooth and dark because when, like we were talking about, lava comes out of a volcano, right? It settles down, and when it cools down, it makes nice smooth rock that smooths over the craters. So that is actually where the Apollo 11 landed in the Sea of Tranquility. And if you take a look at this picture, you could see that those big dark spots, those are the Maria. So Io, a moon of Jupiter, more than 400 active volcanoes, which brings me to a very interesting point. Earth and Io are the only bodies that we know of in our solar system that actually have volcanoes that spew hot lava. All right, so if Earth and Io are the only ones that have volcanoes that are still active, why are we here? Did I just make this video to talk about dead volcanoes? That would be kind of boring. So, drum roll please. We're going to talk about Saturn now. Prepare for things to get very exciting. Sun's hot, right? As you get further from the sun, it gets colder. So Saturn's pretty cold. How can you have hot liquid rock coming out if it's so cold? There's ice volcanoes. It's so cold out there that they have ice volcanoes, and those are called cryovolcanoes. I know, crazy. The difference between a regular volcano and a cryovolcano, aside from, being hot and cold. So a cryovolcano, it is also heated from the bottom, right? But the difference is that it is heating up a liquid, right? So it's a little bit of, well, it depends which moon we're talking about, but water and other things that we normally think of as gases here on Earth. So carbon dioxide, methane, nitrogen, stuff with really, really, really low boiling points. So what happens is the heat from underneath, right? So the tidal heating, oh, this is fun. So the reason that the inside is heating up is called tidal heating. So this is the best way I can think to explain it. If you take your cheeks, right, and you go like that, so the friction of your cheeks rubbing on your teeth, right, you could kind of feel them rubbing against each other, that would be tidal heating. So the moon is going around the planet, right? Tidal heating, it's pulling on it. And if it has a particularly elliptical orbit, so if it's not going in a perfect circle, right? If it's going like that, it's going to be pulling it and squishing it a lot. So that causes tidal heating. Then from the inside, right, it's heating up. That heat needs to go somewhere. It heats the pressurized liquid water pocket underneath the ice sheet. Once you start heating up that liquid, right, heating it makes it expand, that creates pressure, and it comes out of the ice. And hence you have a cryovolcano. Right, so Enceladus, Saturn, has the best documented active cryovolcanoes. They didn't even discover cryovolcanoes until 2005, which was super recent. So they actually don't really know that much about them. They just discovered that they exist. Plumes of ice vapor and ice particles, and tiny particles of ice are ejected at over 800 miles per hour. So they are as scary as regular volcanoes. I don't know what I would have thought as a child if I knew that these existed. I would have been double scared, even though they're a million miles away. Anyway, I'm going to run through a few other moons real quick. So we've got Titan. Titan is fun because it's the first place where they were observed. So Enceladus has the most well-documented actual active ones right now, but Titan was where they first saw the cryovolcano. There are methane lakes, and the atmospheric pressure is crazy. So on Titan, the atmosphere is really going to be pushing down. Here is a picture from Cassini of the cryovolcano that they were talking about. So like a nice picture of it. Excellent book that you should check out if you're interested in sci-fi. It's called The Sirens of Titan. One of my favorite books. Highly recommend.